ዌልካም ኤቭሪዋን በሌላ ፕሮብለም ተመልሻለሁ። በዚህ ፕሮብለም ላይ የምንመለከተው ቶፒክ ነው ኮንዘርቬሽን ኦፍ ሞመንተም ነው። ሶ ጥያቄያችን ምናልባት የተወሰነ ለየት ያለ ፊቸር ሊኖረው ይችላል። ግን ምንድነው የምንጠቀማቸው ኪ ኮንሰፕቶች ያው የሚታወቁ ናቸው። ሶ አንዳንዴ ያው የምናውቃቸውን ፕሮብለሞች ለየት ከፕሪቪየስሊ ካየናቸው ኮንሰፕቶች ጋር ጨምረን መስራት መቻል አለብን ማለት ነው። በዚህ ፕሮብለም ላይ እንደምትመለከቱት ማስ ስፕሪንግ ሲስተምን እና የኮሊዥንን ወይም ኮንዘርቬሽን ኦፍ ሞመንተምን አንድ አድርገን የሚሰራበት ነው። ሶ ወደ ጥያቄው ወደ ማንበብ ገባለሁ። ን ኢንተርፕሬት አድርጌ አብረን እንሰራለን ማለት ነው። So in the figure shown, block 2 of mass 2 kilogram is at rest on a frictionless surface and touching the end of unstretched spring of spring constant 100 Newton per meter. The other end of the spring is fixed to a wall, and block 1 of mass 4 kilogram traveling at speed v1 5 meters per second collide with block 2 and the two blocks stuck together. So when the blocks momentarily stop, then the question says by what distance is the spring compressed? መልካም ሶ እንደ ጥያቄው መሰረት አሁን እዚህ ጋር እንደምንመለከተው here we have block 1. So block 1 initially it travels with speed of v1 to the right, and እዚህ ጋር እንደምንመለከተው block 2 initially at rest now, and it's also attached to a wall, a fixed wall here. And this wall, the spring constant in which the block and the wall attached is K. Of course, from the given information here, the mass of the first block, let me indicate here, the mass M1 is 4 kilogram. And of course here M2 is 2 kilogram. Another thing we have given this given information is v1 is 5 meters per second. So according to the question የተጠየቅነው here ምንድነው አሁን ሁለቱ ብሎኮቹ ኮላይድ ሲያደርጉ ልክ ኮላይድ ካደረጉ በኋላ they stack together በአንድነት ተጣብቀው በተመሳሳይ ዳይሬክሽን ከስፕሪንግ ጋር አታችድ ከሆነው ብሎክ ጋር ይሄዳሉ። ሶ በነገራችን ላይ ሌላ መርሳት የሌለብን እዚህ ጋር ኢንዲኬት እንዳደረኳችሁ ይሄን ፕሮብለም ከሰራን በኋላ we will also find the angular frequency of oscillation. So ሁለቱም ማስ አታችድ ከሆኑ በኋላ they will oscillate back and forth. So back and forth oscillate ሲያደርጉ they will have a certain angular frequency, and we will find that angular frequency. Now the first case would be find the minimum distance in which ሁለቱ ብሎኮች attached ከሆኑ በኋላ there will be a transfer of energy from mass 1 to mass 2, and when two are combined together they will go and they compress the spring by some distance. Let's say that's distance x. Now the question would be what would be this compressed length of the spring. So the compressed length, so of course this distance x could be found from conservation of momentum and conservation of linear momentum, conservation of energy and conservation of linear momentum. So ምንድነው እዚህ ጋር አድ የምናደርገው የመጀመሪያው ኪ ፖይንት from the conservation of inelastic perfectly inelastic collision, when the two blocks collide together and move in the same direction, we will notice that the momentum initial of our system equals the momentum final of our system. So ምንድነው የምንመለከተው ከዚህ ብሎክ 1 የሚኖረው ኢኒሺያል ሞመንተም ይኖራል, and also the block 2. So m1 times the initial velocity of block 1 plus m2 times the initial velocity of block 2, let's say testing V1 and V2, and this would be the final moment of the combined mass. Let's say V final, this V final times the combined mass M1 plus M2. So these two masses are combined together and move the same direction. So this is actually from perfectly inelastic collision. Inelastic collision. So this concept የለም። So the final velocity of the combined system here ሁለቱ ማሶች እዚህ ጋር የምናያቸው ሁለቱ ማሶች የሚሄዱበት combined velocity which say VF. Now this from this conservation of from the conservation of linear momentum, we would find VF. That would be simply here substituting the whole information, M1 V1 plus M2 V2 divided by M1 plus M2. But እዚህ ጋር ሪማይንድ ላደርጋችሁ የሚገባው the initial velocity of block 2 is 0, since it will be cancelled out, and finally the final velocity of the combined system will be M1 divided by M1 plus M2 times to the initial velocity of block 1. So አሁን ኪ የሆነ ኢንግሪዲየንት አግኝተናል እዚህ ጋር። ሶ ከዚህ ኢንፎርሜሽን ምን እናያለን? from the conservation of energy, total mechanical energy, the energy before, the energy at equilibrium point is equals to the energy at a maximum compressed length. So what will happen is, ልክ ስፕሪንጉ ሁለቱ ማስ collide just after collision, they will start to move to the right, of course, until they reach to a maximum distance. This x max is that we are going to find, but this attached mass will have a maximum kinetic energy, of course, at x equals to 0 when springu compress ከማድረጉ በፊት ማለት ነው። ሶ ምንድነው የምንጠቀመው? The kinetic energy at equilibrium maximum equals to the potential energy maximum. This is of course from conservation of mechanical energy. We will find a maximum compressed distance. So the kinetic energy would be maximum. We know that it would be maximum at equilibrium point. So that would be half times mass 1 plus mass 2, because these two masses are combined. Strike ስላደረጉ አንድ ላይ ስለተጣበቁ they will move in the same direction and they will move in the same velocity. So m1 times m2 times the velocity of the combined mass v final squared. So እነዚህ ማሶች እንደ አንድ ሲንግል ማስ ነው የምናስባቸው በዚህ ኬዝ. So this should be equal to the potential maximum potential energy of the system, but the potential energy in this case is the spring, the elastic potential energy. That would be half times spring constant k times x squared. X is የኛ ዲዛይር የምንፈልገው ሪዛልታችን ነው። So here we don't need the half term here. So finally with simple substitution we would find that x squared equals what? m1 plus m2 divided by k. Of course, this is times vf squared. Now, here with simplification, and simplify ማድረግ እንችላለን። ምን ማድረግ እንችላለን? x is simply equals to under radical of, or vf times under radical of m1 plus m2 divided by k. now ምንድነው የምናደርገው? መጀመሪያ ላይ አንድ ነው መሄድ የሚጠበቅብን። መጀመሪያ ላይ ምን አይተናል? from conservation of momentum we have found that this result. so ይሄኛውን ሪዛልት የት ነው ሰብስቲቱት የምናደርገው? so መጨረሻው ሪዛልት ላይ እናስገባለን ማለት ነው። so here x would be the final velocity, which is here m1 divided by m1 plus m2 times v1. So m1 divided by m1 plus m2 times here with this quantity square root of m1 plus m2 times k. Of course, finally we would have a velocity term. Let's put here v1 አለን። So now የተወሰነ simplification ነው የምንጠቀመው እዚህ ጋር. So this implies x is equals to v1 times m1, and finally from this information let's put m1 plus m2 into square root ውስጥ ማስገባት ብችል it would be square term. That case m1 plus m2 divided by m1 plus m2 squared times k. So here the square term would be cancelled, and finally x equals to v1 m1 to be square root of 1 over m1 plus m2 k. In fact, generally x, the compressed length, should be v1 mass 1 divided by square root of k into m1 plus m2. So finally substitute ማድረግ ነው. So from our given information v1 is 5 meter per second and m1 is ወደ ላይ ማየት እንችላለን ከኢንፎርሜሽናችን m1 is 4 kilogram, here m2 is 2 kilogram. So this would be easy. This is 4 kilogram and the spring constant is 100 Newton per meter, and of course the sum of the mass 2 kilogram plus 4 kilogram. Okay, here, sorry. And with simple substitution here you'd get approximately 0.8 meter. So this would be the in shorthand form. So generally the compressed length would be this one. That's nice. And finally መፈለግ ያለብን ምንድነው ከጥያቄያችን now ሁለቱ ማሶች ኮምባይን ከሆኑ በኋላ ምንድነው የሚፈጠረው? ማስ ስፕሪንግ ሲስተማችን ላይ oscillation ይፈጠራል. So oscillation will have its own angular frequency. So angular frequency of combined mass will be what? Here the angular frequency will be square root of the spring constant divided by the combined mass, that is m1 plus m2. And ከዚህ ምን እናገኛለን? This would give us, this is under radical of 100 Newton per meter divided by 2 kg plus 4 kg. Of course, using simple calculation, primary ስለሰራሁት ሪዛልቱን cross check ማድረግ ትችላላችሁ. You'd get about 4.1 rad per second. Don't forget angular frequency ስለሆነ it should be expressed in terms of rad per second. That would be the angular frequency. And of course you may ለራሳችሁ as a given curiosity ከዚህ information ተነስታችሁ you may find a period that would be period could be found from the 1 over frequency, or simply first you may find the frequency of your oscillation. That would be of course omega divided by 2 pi, and you may go on and find the frequency, the period, that would be 2 pi divided by the angular frequency. ምናልባት እንደዚህ አይነት ነገሮችን ጨምሮ መስራት ለእናንተ ይጠቅማል ብዬ ስላሰብኩ ነው። So I hope ይሄኛው ፕሮብለም ላይ የተወሰነ አይዲያ እንዳገኛችሁ ተስፋ አደርጋለሁ። በሌሎች ፕሮብለሞች እመለሳለሁ። ሶ አይ ዊል ሲ ዩ ዜን